The public address or PA features of Q-Sys allow for easy management of audio announcements via either a live microphone or a recorded message to one or more zones located throughout the facility controlled by your design. The PA router is the core component in a PA system and manages the routing of audio to the various zones. Normally, the PA router is controlled by virtual page stations or hardware paging stations from QSC or another vendor through their own plugin, but it's actually quite easy to control the PA router from your own script using the Lua PARouter object. This, along with the PAZoneStatus object, which allows you to receive status notifications when a PA zone becomes busy or free no matter what station is occupying it, is part of an undocumented library in the Q-Sys Lua scripting environment. Although these objects are not documented, a lot of information for the PARouter object can be gleaned from the PARouter API documentation as part of the QRC protocol, and the PAZoneStatus object is quite simple, since all it does is raise events with a table containing either 2 or 4 values. Today, I want to show you how to get started using the PARouter and PAZoneStatus objects with a brief introduction to their functionality. For this lesson, I have a text controller with a push-to-talk button, 8 zone buttons, a station number and priority selection, and a few indicators to tell us what zones, priorities, and tags are available, as well as the current status of each zone. All of these are shown here in the top left corner. In my design, I also have a PA router and virtual page station, which we'll use to demonstrate the feedback function in the PAZoneStatus. I also went into Administrator and set up the priorities, zones, and tags as shown here so that I can demonstrate the ability to view all of this information later. With that settled, we can work on our Lua code. The code we're about to write can be broken into 4 tasks. First, we'll pull out the current paging configuration from the design. Second, we'll submit a page to the PA router with our desired zones, priority, and any other settings we want to include. We'll do this on a change in every control except the push-to-talk. For the push-to-talk, we'll either start or stop a page depending on the button state, and since the page handle expires after ending a page, we'll submit a new page after completing the last one. Lastly, we'll update our zone status LEDs when the status of each zone changes, even if that change came from another source. So we will start with our first goal, getting the paging config. The paging config is stored in the file structure of the design during run or emulate mode as an XML file, which looks like this. Feel free to pause if you want to take a look at it more closely. To read it, we'll start by requiring the Lua XML library. Although this library can read XML files directly, I have not been able to get that to work properly in Q-Sys, so we'll use the IO library to open the file, read the entire contents to a string, then close it. Once we have that string, we can use Lua XML to evaluate it and get a table containing our data. Now, we'll go through the 3 sections we care about and collect the names of our tags and priorities, as well as the names and indices of our zones, and store them in a set of tables for easy access. We'll then send that data to our text indicator so that we can see it while the design is running. We could use these values for things like populating a drop-down list on a plugin or validating the selected item as we work, but this video is already going to be long enough, so we'll skip that part here. Our second goal is to submit a page to the PA router upon a change in the controls. To do this, I'll create a function that can take in a list of zones, which can be integers or strings representing the zone name, a list of tags in the form of strings representing their names, and a priority value in the form of an integer which is actually 0 indexed, so it needs to be 1 smaller than the value shown in Administrator. First, I'll do some quick validation to make sure we actually selected a destination and set up this page started variable so we don't try to submit a page while one is running. Next, we'll set up the parameter set to send to the PA router with the mode set to live, the priority to our control value -1, and the station to our selected value. Then we'll add the zones and/or zone tags as they're chosen, and lastly, use a pcall to submit the page, since the submit may raise an error if there's a problem. We will also catch and print that error. Once we submit the page, nothing visible will happen in our PARouter. This is because submitting a page only tells the PARouter that we intend to make a page, but doesn't actually start the page. If a page submit was successful, we'll get back a handle which is used in subsequent operations to start, stop, or cancel the page, so it's important that we store that handle for later use. Our third goal is to start and stop the page when the push-to-talk changes status. This is a fairly simple step where, if the PTT is on, we'll make sure we have a page handle, start the page, and set our page started value. If the PTT is off, we will stop the page, assuming its handle exists, clear the handle, set page started to false, and submit a new page so that we can be ready for the next one. We will also create an event handler for the PARouter to capture incoming events. These are generated only for pages which we submit, and there are a few events that can be sent, but here we will only look for ones where the state is done, to indicate that we either stopped the page ourselves, got interrupted by a higher priority page, or timed out. We will use this to clear the page handle, set our page started variable to false, and clear the PTT button state. Our fourth goal is to update our zone status LEDs. To do this, we need to create an event handler on the PAZoneStatus object. This handler will be called once for each zone and indicate the zone number and whether or not it's active. If it is active, it'll also indicate which station is paging to it, as well as the priority of that page in the structure shown in the comment here. For this lesson, we'll simply set the zone status LED's Boolean value to that of the zone's active value, and we'll ignore the station and priority values. With that done, we can save the file, go into emulate mode, and take a look at our configuration info here with the tags, priorities, and zones that I set up earlier. If we set an arbitrary station number that isn't already being used by the virtual page station, select a few zones, and hit the PTT, we'll see that our page is now running and the LEDs reflect that. If we stop the page and start one from the virtual station, our LEDs show that the selected zones are now in use. And lastly, if we increase the priority value of our station, which actually lowers the priority, start a page, then interrupt it with a higher priority page from the virtual station, our first page gets stopped and the PTT button gets released. This was just a small sample of the features available in the PARouter Lua object to get you started using it in your next design or plugin. As previously mentioned, this takes a lot of similarities to the QRC PARouter API, so I encourage you to look at that documentation for more methods and parameters that may work with this library, as long as you remember that it's not an exact duplicate. I hope you learned something. Thanks for watching.